Oke, nama saya El. Di sini saya nulisnya sebagai founder dari DevOps Focus Group, salah satu komunitas buat belajar DevOps di Indonesia. Tapi di lain itu saya juga sekarang bekerja sebagai Principal ML Ops Engineer di salah satu perusahaan di US namanya Korai, and also sebagai IT konsultan di salah satu konsultan company di Eropa namanya Alice. Untuk topik hari ini tuh kita akan bahas tentang distributed data and training sebagai machine learning operations on Korai. Jadi nanti kita akan bahas beberapa hal. Oke, kita akan bahas mulai dari apa sih visi dari Korai sebagai perusahaan dan masalah apa yang sebenarnya dihadapi oleh Korai dan apa yang mau kita solve gitu. Kemudian nanti kita akan jelaskan juga tentang gimana infrastruktur kita secara gampang bentuknya seperti apa, karena kalau konseptual cukup advance gitu. Kemudian kenapa kita memilih Kubernetes dibandingkan teknologi lain untuk menjalankan machine learning dan training kita. Terus kemudian dilanjutkan dengan alasan kenapa memilih Ray cluster dan Ray stack keseluruhan, dan apa yang dibantu solve oleh Ray stack di challenge yang dialami oleh Korai. Kemudian kita akan lanjut dengan key benefit yang didapatkan setelah implementation of Ray, and then challenge and lessons learned from the Ray implementations. And lastly, maybe we'll be talking a little bit about our future directions of Korai at the company levels and also at the technical levels. Okay, so in the US, the number one cause of deaths for children under 4 is actually drownings, because like in half of the house in the US, they have swimming pools, and these swimming pools are not built with fence, so a lot of children are dying from drowning. So we want to fight this, and actually in the globally level, there is like more than 30% of the cause of death for children is actually from drowning. So we want to integrate AI, we want to integrate computer visions to make sure that we can prevent and we can lower this number. We are learning from the smart car, because in the smart car you can detect any movement from the other cars in front of us from the camera. So we change this into 3D. So that's what we are trying to do on Korai. Sorry. We have the video. So these are a little bit of a showcase how the infrastructure, the applications would look like. So we will have 2 cameras in 2 directions, camera 0, camera 1, and then these are going to provide us with a 2D image. And this 2D image is going to be 3D reconstructs and change from pixels to point cloud to a voxels. And from a voxels data, we can create a gamifications so that it can be displayed, something like this. And we will integrate AI and machine learning to understand at what age is someone who are currently playing around on the swimming pools, and then, and then the danger levels would be different between age. So if you are someone, if you are on a teenagers, then going in on the pool for 10 minutes is no problem, but if you are a children, going in more than minutes going to be a problem. So this kind of knowledge, this kind of learning needs to be done on our models, and that's where the challenge coming. So this is how our infrastructures look like. We have 2 cameras and we have a single edge device. This edge device is using a Jetson machine, and then this edge device is going to be the brain that store our models. It's also going to be the device that send all of the video to clouds, and then from clouds we have some machine learning and data pipeline process happening with Airflow, with some Ray cluster. So there is a lot of things that happen behind the scenes. From raw video, we try to split it with the video clipping to make sure that the video is only like 20 seconds or less, And then we filter the video if we have a good data, if it's have like a people in it. If it don't, then we just move it to archive. So there is indexing, annotations, and once we have all of that, the data processing is done. We are moving with the scene reconstructions. So from the 2D image, the two-pair image, like pair frame, we change that into a 3D. We have a foreground 3D, we have a background 3D. The foreground itself is only creating the peoples that walks that dynamically behind the pools, but the the background is the pool itself, which are not changing. And then once we have all of those informations, we are going to use this data, all of the annotations, all of the informations to train our models. And then once we have the models, we will deploy that. The main problem with this whole infrastructure is that the first one is the training and the data processing do not happen 24/7. We are not going to serve all of the process all the times, like a website, for example. So we need some infrastructures that can scale up and scale down effectively, and if possible, scale down to 0 if there are no requests. And then we have a lot tools for those overall process, and these tools are usually different, like not a singular programming languages. Also, for whole process, there would be a different requirement for the resource. For some training, we might need a bigger GPU. For a 3D reconstructions, we would need low GPU but a high memory, things like that. So this overall challenge is what prevent us for training faster. Before we integrate Ray, what we are doing in Korai is that we will train like from 10 terabytes of data, and it would take, based on estimations, it would take us 27 years to finish the training, because we do it on a VM. So that's why, moving forward from those issues, we introduce features on clouds. We are leveraging GKE or Google Kubernetes engines, and we choose the autopilot cluster. So why do we choose autopilot cluster instead of the standard one? The first reason is that it's fully managed, because we are only 4 people. The company itself is only 4 people, and we want it to be removing the overall management process to the cloud providers. We want it to be cost optimized, because we only pay for what we have and what you use, which is the pods. We don't have to manage the nodes, things like that. And then in the end, we want to be able to leverage the CPU and GPU creations in a simple way. That's why we choose GKE. Okay, so before we move forward with the next topic, which is EasyStack, we have to understand what is the distribute training and distribute data. In the VMs, if we have a data and we all do training, we are going to only use a single, not single GPU, like the overall CPU that we have on the device, on the VMs, on the server, for a single training process. We will use all the resource for a single training process. We will store all the data in a single places. We can use like a bucket, we can use a disk, and these are going to challenge us when we want to scale the training process, because everything is done in a single area. So we, in a simple way, we will distribute everything into multiple workloads, multiple cluster, and that's why we integrate Ray, which is like a cluster inside cluster on Kubernetes. So the first reason we choose Ray is simply because Ray provides us with a consistent and unified Python API. So next time we create all of those processes that I mentioned before, all of this process can be written in Python with the module already prepared by Ray cluster also. And it can also scale the jobs, tasks, and all the process on our training and data pipeline efficiently with their logics. And then it supports multiple machine learning library like PyTorch and also TensorFlow, and it can also integrate with third parties such as MLflow, things like that. And lastly, one of the most important is that it supports node failure, which is a mechanism for us to continue the training process even if one of the nodes is down. that's are the biggest challenge that we want also to overcome, is because training process sometimes happen like maybe for 2 weeks, 3 weeks. If there is any nodes going down at those time, and before the training process is finished, then we have to start from zero again. So we want to have this node failure handling capability, and that's why we integrate these tools. So the first the first stacks that we use from the array cluster, from the array stack, is the array cluster itself. Array cluster is a node management of array, and when we translate that into Kubernetes, array cluster is actually creating a group of nodes, but it's not a Kubernetes nodes. It's creating pods, and these pods is going to be act as a nodes. Okay, jadi pods-nya nanti akan dijadikan nodes oleh si array cluster gitu. Jadi node-nya array cluster is different with the Kubernetes nodes. And this array cluster enable us to create multiple cluster, multiple worker groups. First one, for example, we create 3 different cluster. The first one with data processing, which don't need any GPU, because they are just going to do video filtering. They want to annotate. We can use a CPU. So it's only CPU and memory type of workload. And then the second cluster is a 3D reconstructions, which is using a memory with high intensity. And then the last cluster is for training with the highest GPU requirement. So these 3 cluster can run indefinitely, and we can send jobs to the array cluster API, and then we can select what requirement do we need. Like for example, I want to have a high CPU resource, then it would deploy to the CPU cluster. And then with array cluster, we can enable the auto scaling, which help us with the scaling to 0 and scaling to, I can say that unlimited resource as long as you have the quota on the cloud. So that's what we leverage. And then the main reasons we also want to use the array cluster is because array cluster support the bootstable pods on Kubernetes. So we can set, for example, a node with a request only 1 gigabytes of RAM, let's say, and we can set the limit up to 100 gigabytes of RAM, and these are work really smoothly with Ray. So that's why we choose Ray. So these are how Ray would works. So we have the head nodes, we have the worker node, but once again, these are not Kubernetes nodes, these are a pods. So inside the pods, there should be like a head pods, worker 1 until worker n. So the number of worker would increase. And inside those head, there would be autoscaler, there would be the global control score, and all of the controller resource would be on the head. And the worker would be scaling up and scaling down once there is a request and once the process is done. And all of this process, all of the monitoring, all of the checking, health check is done by Raylet. For someone who works with Kubernetes, you might be familiar with Kubelet. The concept of Raylet is almost identical, but maybe just this, different comments, but it's almost identical with how Kubelet is working. So we have Raylet here. So basically, Ray cluster is a cluster inside a cluster. But integrating Ray cluster to the Kubernetes, it's not really simple matter. If you just create it from your YAML files, it would take a lot of times, because there is a really complex structures you need to work, and they are not following like a standard deployment or standard stateful set format. And also, you need to have the RBAC, things like that set up. That's why Ray introduced a kube Ray, which is a controller and operator on a Kubernetes that can help you deploy those Ray cluster in a simple way. So by deploying kube Ray, then we can have deployment with Ray cluster YAML. So we don't have to create deployment YAML with the Ray image and all of that. In GCP, especially on the GKE, you can enable Ray cluster directly by just checking the checkbox. But I still recommend to use the Helm from the repository, which is quite more up to date. So kube Ray is a must for me if you want to use Ray cluster on the Kubernetes. Okay, so these are how it would look like on Kubernetes for array. We will have the underlying infrastructures of Kubernetes. You can choose your self-host Kubernetes. We can choose the AKS. You can choose the GKE. And then above that, you will install the operator, which is the kubearray. And inside kubearray, you can just create the array stack. You can create array jobs. You can create array cluster, array tags. All of the array infrastructures can be installed and managed by the kubearray. And then above that, there would be some API endpoints that you can use to communicate with the array cluster. Okay, so the next issue that we have is that we are managing almost 10 terabytes of data for development process only. So these are only development data. It's not the production's data. And the process of filtering, the process of training is hard if we have like multiple buckets, multiple folders stored across our storage, and we want to have like a singular management for the data with the annotations, with all the mapping, with all the pointers. So Ray introduced us with the Ray data. So Ray data can help us to manage those data which have a different format, a different locations in a more standard way, so that it would be easier for us to use it for training. So Ray data is, I believe, a simple, not a simple, but like you can create a Python script with the format of Ray data. You can use the functions from Ray data, the module from Ray data to create more standardized versions of your data sets. Okay, so Ray data comes from the word of data sets. Okay, and then once we have all of the data in a single format, it's already been sharding, it can be distributed for training purpose to the next tech stack, which I still redacted because we will introduce it on the next one. So the next task that we are using is Ray Train. As the name suggests, this is a tool for us to train the AI and machine learning, the models itself. By doing Ray trains, it would be more efficient for us to have the database, the data sets in the Ray data, and they will just train it based on the logic that we share or that we set on the overall model trainings. And the best thing about Ray train is that by default, it is already been like built in with the capability of choosing a GPU and CPU from the nodes. Let's say you set a node to have like a 2 GPU, and you train a single epoch of machine learning training with the requirement of one single GPU, then those nodes can run 2 epoch at the same times, or like 2 process if I have to mention. That's why rather than using like a multiple tools in Kubernetes, we just want to use a single stack, which is the Ray stack. Okay, so what do we get from implementing this? I believe I used like 3 months for implementing all of this Ray stack with the teams. Before, we can only run like 100 or 200 jobs per day. And right now we can run millions of jobs. And this is really, in fact, millions of jobs. I can say like 7 million of jobs at the same times, as long as the quota allows. And then it's really on demand. So you can scale 0, we can scale to 1 million of nodes. And then by integrating Ray, as I mentioned, we integrate everything in the Ray stack so that all of our process can be managed with a single dashboard of the Ray dashboard. We are able to handle 10 terabytes of data with only 4 individuals, and we are successfully decreasing our monthly cost, infrastructure costs by 91% from like around 62K per month, of 62K USD per month. When you are using VM, you can decrease it into like 6K USD by using automator. So it is like almost 91% of like downscaling on those pricing. So these are what we get by implementing Ray, integrating it with the autoscaler functions, and then use the node, like use the autopilot to help you to choose the nodes, just creating the pods. But implementing that would not be as easy as what I said. There is a lot of challenge that happened during those 3 months of process. The first thing is that this is the main challenge is Ray head should not run any workloads, should not run any jobs, because they have to manage the nodes behind them, and if they have a memory issue, the head node would restart, and all of the data, all of the worker node would also be deleted. So we have to make sure that the Ray head do not handle any jobs. And we can do that by just setting the parameter of the number of CPU and memory on the Ray head to be 0, even if it have a memory. In the Kubernetes manifest, it has memory, but in the Ray, they don't detect the memory because we set the parameters to 0. And then by default, Ray cluster API do not support RBAC at all. So we have to set up a Kube RBAC proxy as a sidecar. Yeah, so there is like another issue, like this you say it's zombie node issue, and the jobs is taking too long, but all of that can be solved if you, like for example, integrating the features from the most update on the, let's say they have this community on Discord, they also have this community on Slack, so you can follow that. Yeah, these are the last slide. The future directions of having Ray is that we will going to integrate RayServe to serve the machine learning models and setting up in the endpoints so that we can access those machine models and we can communicate with it. We want to have the enhanced on-site integrations so that the models are not deployed on cloud, but we want the model to be deployed on the on-premises so that the thinking process can be done on the Jetson edge device. And then we want to have a federated layering, which is still far off. Okay, so that's it, and thank you.